welcome to SIM-PAC Live. I'm your host, Jeff Matthews, and today I talk to Craig Nicol from the Graphene Manufacturing Group. Welcome, Craig.
Hi, Jeff. It's good to be on.
Great. First of all, graphene, the wonder material, the thing that's going to change all our lives. Tell us a little bit about the history of it, because it's only really a last 2-decade development, and how an Australian company like you ended up being at the forefront of its development and the implementation of its use in industry.
Great question, Jeffrey, and it's best over a bottle of wine, actually. It's a lot to take in. We're now almost 9 years old, so, lots of troubles and tribulations to work through and explain, but really, graphene is a carbon powder, and there's 4 different types of carbons. You've got diamond, you've got coal, you've got graphite, and graphene is the 4th one. And it was identified about 20 years ago, and somebody got the Nobel Prize for it. So they realized how amazing it was. It does lots of different things. It adds a tiny bit of black powder of this, adds a lot of things to different elements of different types of outcomes. It's very strong. It's great at lubrication. It's great at transferring electricity. It's great at transferring heat. So it becomes like this magic powder. And I think it really found trouble trying to work out how it was going to get into people's applications. But I often say, graphene is going to be like silicon, which is the material that really changed our lives. Silicon chips, and arguably no one sees silicon material at all these days, but it's completely changing. It's the only reason why we're talking to each other right now. So graphene will be like that, where you'll see one day things change and will be better, and you won't know why, but it'll be graphene, probably somewhere in the equipment that's making it better. And soon you'll see graphene chips come out, which are 1,000 times better than silicon chips. But what we have done with GMG is to use graphene in energy saving or heat transfer products. So we have one product here called Thermal XR, which improves heat transfer. So you can spray that on your air conditioner or large processing equipment, and save energy, usually about 20% or so. And we have a G lubricant here, which is a graphene engine oil that can add into your engine and save up to 8% right now of fuel. So those are very new, and that's what graphene provides: heat transfer and also lubrication. And we're also working in new battery technology, developing an aluminium ion battery with Rio Tinto. So that's the space we found. We realized it's very difficult to work with. It's a powder that is very difficult to actually mix in. So we had to go into the downstream and pick these very large markets, and that's where we're in. So then we're whole value chain now. We make the graphene, and then we make these products, and we sell them online and through various different distributors and OEMs around the world.
Yes, and your manufacturing processes are proprietary and they're world leading. And tell us what you do differently than other people manufacturing graphene around the world.
Yeah, we had a number of ways we wanted to start up when we envisioned making graphene, and really the best and available source of carbon atoms, which is what graphene is in natural gas. Natural gas in Australia is 98% methane, 2% nitrogen. My background in oil and gas company, I worked for Shell for 20 years before this, allowed me to understand how basically you got 75% or 3/4 of natural gas are carbon atoms. So the gas you cook your eggs with in the morning is 75% carbon atoms and 25% hydrogen atoms. And you just got to work out a way of getting them out of the natural gas. And we worked that out. And so we were the first company in what we believe is, and really the world leading company that can actually extract those carbon atoms out of the methane. And then we left with some hydrogen doped methane. So it becomes a greener gas after that. Now we can do that with standard gas, and we can pretty much do that. We think we can do that anywhere in the world. So that was a very, very mobile platform. And we developed this because we thought, usual way that Australia has fallen behind, and we really need to step up. But what actually came, the fact was we launched it, and we said we made graphene from natural gas only and nothing else. And we found out we were the only ones who'd ever done it, which, you know, is a bit of a thing I found. Building this whole factory from scratch, we had to use a lot of local manufacturers' knowledge, and a lot of the world-leading companies materials and technologies that we needed were actually in Australia or one street away. And you wouldn't know until you searched for it, and then you found it, and you realize actually they're just one street away. I'll use those guys. They can give you that particular piece of technology. So we had to really, you know, and then we started to learn that actually Australian manufacturers really are world class. They're just well hidden. And then, you know, we became one of those until now we're obviously a public company, and we have our products for sale.
And you publicly listed in Canada or the US? In Canada.
Yeah, so we're listed on the Toronto Stock Exchange Ventures in Canada. We're also on the OTC exchange in America, and we're also in German exchanges as well, TradeGate it's called. We're currently looking at ways to, and we've already announced this, to list on a large American exchange, which we think that's our natural end home. We are an Australian public company, but we're actually listed for capital reasons in Canada.
Right. And this is an example of an Australian manufacturing or technology developed in Australia, you know, that's world leading and is able to spread Australian fingers across the globe.
Yeah, so all of our technology is developed here. All our operations are here in Brisbane, Australia. And, you know, we really are focused on world-leading technology. We'll release our first version of something of our products, and we're already working on our second or third version, you know, generations of the products and technologies continually. So, you know, we can do things for our customers and our focus on different types of equipment, say, or data centers or appliances for our coatings. And we're already seeing how we can help them on the next stage. So, you know, we're helping them on the initial focus, and we're trying to get them there so that they can use our products so that they can start becoming more energy focused or reduce energy in their operations. But then we're also looking at the next stage. So we're not in any way resting on our laurels so far. Yeah, and a lot of them have got patent pending or very close to being fully patented as well. So we'll bring that in, but nothing is as good as just keep getting new technology rolled out as we start producing the ones that we know are working already.
Yes, I recall a comment you made at SIM-PAC Live Queensland recently, and you said, "Be better and be faster."
It's the only way to be a success is you need it to be better technology, cheaper, and you need to be faster. That's the only way it works. And if you've got one of those, maybe you might have an edge. If you have two, okay, you might have, but you've got to have all three. You need to be faster to market, you need better technology, and you need to be cheaper. And that's literally where we're at with all our products. And, you know, we have our companies, you know, searching and looking into us and often saying, look, I've been watching you for a couple of years and now I can see that you've got to where I want to talk to you. Technology takes a while, especially with energy. You know, it takes a while to penetrate these very large inertia type markets. And that's something that needs to be understood. It's not as fast as you'd always want, but when it's there, it doesn't stop because the inertia is built.
Yeah. And looking through your products, you've got where you're using it. You've got the heat exchanger coatings, which are really using the thermal properties of graphene. And that's when you mentioned data centers before. I'm assuming that you're able to have cooling, and you're able to the heat sinks are able to operate better with graphene coatings. Is that correct?
So there's many different ways that we can provide. So you got things like this. It's just a metal plate. So that will have 9 times more cooling of radiation and 2 times overall when you're including air. So 2 times more heat transfer off that. So that will be, you know, a good 15-20% cooler. This metal, depending on the temperature, some up to 50% if it's really hot, hundreds of degrees. And that means you're moving heat faster, and that means you're saving time to get to the temperature, and that means you're saving energy. That means you're saving emissions. It's
Yes.
the whole world is governed on heat transfer, and yet they all thought until we come along that heat transfer was fixed. Heat transfer rates are not fixed. We can fix them. We can change them. People thought they were about metals. Somewhat they are, but also it's around the interfaces, and we improve the interfaces between the metal and air. And they can be used on heat sinks, on even things like appliances. You can talk about phone cases, computer chips. You could talk about obviously air conditioners, refrigeration systems. You can talk about large processes where things need to be cooled faster, so you can make large materials faster. You can bus bars. You name it. Anything that's above 35 degrees Celsius that needs to get cooler faster, you should use our coating. That's technically what this all the work that we've done with University of Queensland says. Our coating should be sprayed on anything that's more than 35 degrees, and you'll double the heat transfer rate without a fan. And then that means you have less energy and faster time to make it.
And the brilliant thing, you double that without having to invent a new metal object. We're talking a coating, and that means virtually no capital outlay. You're getting to the end of the process where you might have either not or put a coating on anyway. You're actually just you're procuring a better coating and doubling the performance.
Yeah, and you're enabling a new performance outcome with minimal change to the product or the equipment or the factory, and that's attractive. Changing heat transfer rates though is complex and is something that people need to get their head around. It can do some really interesting things, and that's where we help with that technology transfer, or being able to use it. People turn on their phones and know how to use it because they've been using it for decades, right? Well, one day people will know how to use graphene coatings really effectively and transfer heat faster. But with a lot of the work we do modeling. It helps them explain what performance they'll get, and then they'll go and do the testing, and then we provide the coating for that. Obviously, your standard air conditioner can be used. This coating can be used straight away on that. And we are the first. I think we were the first nanomaterial producer to be approved under the new Australian nanomaterial laws under AICD a number of years ago. So we've got all those approvals to produce and sell that in Australia and obviously around the world. We're just waiting on American EPA approval. The whole passage of grabbing, a carbon which doesn't any things, a carbon powder, and then eventually get it to market is a really good example of, having just a lot of patience and a lot of focus and a lot of drive to find a really interesting and massive opportunity that, can really impact the world. And, we do it all here locally. And, one of many amazing Australian manufacturers that are not necessarily well known by many people. We did all this with local manufacturers as well, all the technology that we developed as well. So there are many reasons why, Australian manufacturers are what they are. And, we aim to just continue that. That Australian manufacturers often have got, a bad rap, potentially for different reasons. Maybe it's just for cost overruns for different parts, but they really do bring in quite amazing technology of science, and they really do try to keep a low profile just so they can get their jobs done.
Yes, I've looked at what's happening in the United States with Trump wanting to reshore manufacturing there, and I think there's a very old-fashioned view of what manufacturing is. It was making, sewing up cheap T-shirts or making widgets, and
Mm.
and we've got to move beyond that and look at, you know, what is manufacturing today, and what's high value manufacturing, what's high tech manufacturing, and as you said, what's that science, what's a competitive advantage, and it's not sewing up cheap t-shirts.
Yeah, and that's a transition that we've all got to take people on, and maybe manufacturers probably haven't done good enough job there, but certainly the energy kind of transition, Australian manufacturers can step up and can do amazing work. There are some amazing you and I both saw them present at the last SIM-PAC Live, and they're just world leading, absolutely world leading. We've got guys here who do stuff and they're a supplier around the world, but very few people would know who they are. And I think a lot of ways, as I said, they just like to do that. They like to do their job. They like to talk to people who like their products and like to buy them. And they're private companies, and they do good jobs, and that's what they're trying to do. We're a private company. We've got mass product application. We can basically, any business in the world can buy our product. So we have to be above the line. We have to be a bit more out there. But it's interesting that the response you get sometimes. You go, wow, this all happened in Australia. I was like, this is happening everywhere in Australia. They just don't want to tell people, so they can just get on and do their job and clock off and have a beer. That's the way I see it.
It's great. I love it. It's part of what keeps me going here. It's SIM-PAC Live to tell these stories. They're amazing. Look, turn to one of your stories and talk about a consumer product, the lubricant that you have. Now, this is if you first read about the stats, you think, oh, this is magic. This is black magic in a powder and in a bottle. But essentially, a lot of the friction, or most of the friction and the energy is consumed by friction in the engine. And your graphene added to the engine, you add it into the diesel or oil, it reduces that friction and gives incredible, mind-boggling performance and payback. That's a do now that you could put into any diesel vehicle, virtually any vehicle, and just run through the. And I know that these have been your results have been quantified by University of Queensland, I think. Just run us through those stats, because they are just quite incredible for reducing emissions today.
Yeah, so I've been in Shell for 20 years, as I said, and I've sold a lot of diesel and I've sold a lot of LNG. And I know the market that is to be able to build those supply chains is intense. It takes a long time, potentially decades, in some cases, definitely 10 years, in some cases 5 years, to do really large diesel supply chains. LNG, a bit longer, obviously, because they've got a lot, billions of dollars equipment. And that's not going anywhere, right? There's been more than $1 trillion a year spent on oil and gas, and that's not going to change. I think it's $1.5 trillion spent last year, and it was $1 trillion a few years ago under IEA data. So why is that? You know, why? Well, actually, because diesel and fuel are so energy rich, so energy dense. You know, that they've got right now, you know, 130 times or 60 to 130 times more energy than the best battery per space or per kilogram. There's so much energy, but you lose a lot from heat. But still, they're just. So how can we help? And this is what this is about: is to ease to the emissions and also provide it as a cost saving. Because I think always environmental outcomes improvements should always come through cost savings. Otherwise, I don't think the market's incentivized to do that. And we just want to offer that with our product. So this one here is a 500 ml bottle. It's available right now. It will, you know, there's a saving of around 8.5% fuel saving, and that will go into one truck. So a large rig. There's about 80,000 of those in Australia, about 10 million of them in China. And that 500 ml bottle will go into 50 litres of oil, so 1 in 100. And then in the end, the graphene is only only in total at 0.01%. So 1/10,000th is what's actually the graphene is in the engine oil. And then what that does is it both fills in the wear scars of all the metal, because this is atomic level carbon that we make here. And those atomic carbon pieces fill into the metal score. And so it improves the sealing wherever there's any leaks, any pistons. Also, it lubricates it, because obviously it's carbon, it's graphite. It's well known, it's a good lubricator. It sticks to everything. And there's small, tiny carbon atoms. You're talking less than 10 atoms high and a couple of hundred carbon atoms wide. So they're tiny, very tiny. Doesn't have a problem with your filter. We filter this before we release it as a quality assurance at the end, so we know it's not going to chug stuff up your filters. And then what it does also, it takes the heat out of your engine as well. So it increases your engine oil viscosity and then runs that. So what's called your hydrodynamic thin film effect, which is where your bearing is running in oil. And the oil, it's supposed to float the shaft. And what we're able to do is take the heat out, and then that oil runs on, it actually starts to lift the shaft up. And that's where you start to see the fuel savings as well. There's a few other things that we know it's doing as well, but they're the main two effectives. And you can just ask AI if you want. I use Perplexity. Just ask, how does graphene affect engine oil in an engine lubrication? And it'll tell you.
What's the payback on buying that product and putting it in a rig?
That one's $149. That'll do 10 small cars or one large truck. So one B double or something. That'll save you. It depends on how long your oil change. So if you're doing 10,000 kilometers, that'll save you about $1,200. So the payback is, potentially a week. If you're doing 100,000 kilometers, which some trucks can do, up to 100,000 kilometers oil change, that'll save you 10 grand. So it depends. It's not. It hasn't got a life to worry about. It's more when you drain it out. Well, you've got to put it back in, and that's what I'm talking about. So you've got a few days. If you're running long kilometers per day, of course this works on diesel engines for power generation. It works on construction sites for farmers. There's I think from memory,
any combustion engine,
engine and petrol as well. Yeah, it does both.
Yeah,
it's not just diesel. So, we're focusing on diesel because diesel is generally a business kind of engine, and and also this works really at best at high load. So the higher the load, the better. If it's a low load engine, don't worry about it. Don't put it in. If it's a high load engine and you're just pushing the engine to its maximum, and especially if it's overheating, that's when this will reduce the temperature.
A big truck hauling something uphill.
Yeah, that's what it does. It does really well. That's its focus. And there's an enormous amount of emissions we can save with this one product. I think
it's huge, and it's a do now, and that's what anything done now is great. Okay, I want to come to the aluminium ion battery technology you're developing, and this is a little area close to my heart, because I got up in 2017 at a global aluminium conference in London, and I said, the aluminium ion battery is coming, and it's going to change the world. And I said this off the back of Stanford University's research, and they'd published, and they'd got an aluminium ion battery to work. But it then went into a hole. There was like nothing for you never heard anything for the next years. And then I come across you, and it's like, hey, this is the technology. We've just picked it up, and actually we're making it work. So can you explain how graphene is helping bring the aluminium ion battery technology, or hopefully it is, to a point that it's commercialized?
Yeah, it's a good question. And honestly, it's many PhDs all combined in one to answer it. So let me just see how I go. I'm just a mechanical engineer, right? So I'll try to explain it best I can. The way aluminium ion batteries work is the ions go the opposite to lithium ions. So the ion goes from the anode to the cathode, okay? And in a lithium ion battery, they go from the cathode to the anode. So for a start, you're already mixing up your lithium ion battery chemist engineer's brain. You just, what, the ions go, what? How does that work? Nope. That's what it does. So up front, it's best you don't know anything about lithium ion batteries, because you're going to be stuck in thinking how it works in a lithium ion battery place. So that's why I think a lot of companies didn't pick it up, is because it's so different. It then works on two ways. So there's two different reactions, and that's very strange as well. With lithium ion battery, you only use one reaction in a or type of reaction. We use a plating and stripping on one side, and we use a intercalation on the other side. So we plate and strip the aluminium atom onto the foil. The foil we have is on the anode. So we have nothing coated on the anode. It's just foil. And then that is plated on and then stripped off. And it's very fast. It plate on, off, and that's our anode. Then on the cathode, it is just pure graphene, which we've developed over time to be 100% graphene. I don't know of any company in the world that does only 100% graphene electrode. I can say that because we had some big companies through and they go, I've never seen that before. I said, yeah, well, that's what we just developed how to do it. I just kept on saying we need to do this. So the engineers went, okay. And they went and did it. So we use only graphene basically on the cathode side. So the ion goes in and it finds a hole, and then that enables it to stay in there, and then that creates the charge, and then the electron goes around. So the ion is just an atom without an electron. In our case, we've got 3 electrons, as you would know, and a lithium-ion battery's only got 1 electron. So we've got the potential to be a higher capacity battery than a lithium battery. But up front, why we're working with Rio Tinto, why we're working with others, is we have a really fast charging battery, what's called a power battery, or kind of hybrid supercapacitor battery. And that's what's really attractive. So when the ion comes across, it goes across so fast, we can do things like 60 times faster charging than a lithium battery. And, we can charge in a few minutes, and we still get good energy density, and that's why people are mostly interested in us. Also, it doesn't blow up. That's kind of pretty helpful in a lot of places. It's surprisingly...
I remember reading the original Stanford University stuff, and then they said they could pierce the battery and it would still operate. In other words, you could put a bullet through it and it would still operate.
And the electrolyte is like a bit of detergent. You just, you can wipe it away. It doesn't catch fire like a lithium battery will potentially, if that leaked to the air. So there's a number of benefits. So the main benefit is it can operate with very high heat capacity, so it doesn't tend to have a problem in doing very high load, very high amps. Generally, lithium-ion battery cell can't do more than, say, 1 amp. It can do 2 amps for a tiny bit. Generally, it's 1 amp. So when you see these fast-charging batteries coming out, that's not changing the cell. That's just changing the way the battery splits charge across the thousands of cells. And what we've got, though, is a completely different way of being charged and discharged inside the cell. So the technology is completely different. And obviously, we're aiming to be thousands of cycles long, which is very possible with this technology. We're currently at a battery technology readiness level 4, which means we're optimizing all the different parts. There's about 9 or 10 different dimensions to a battery.
Yeah.
And that makes it interesting. And that's why I went grey. No, I'm pretty sure I went grey before.
Yeah.
But that makes it very interesting, Jeff, because you might get 9 or 8, and then there's one that you go, oh, got to fix that, and then you got to fix this, and then you just go backwards and forwards. So, look, quantum technology for heating and lubricating, that's fine. Making a new type of plasma technology to make graphene, that's fine. But then, yes, the aluminium atom battery is, I think, the hallowed ground. I think you'd probably say from a lot of different companies. But it is challenging, and that's what we're working through now. We're confident we'll get there. We've just got to work through it.
Yeah. And the other advantage, if you get there, hopefully you get there, is it's a really established and cheap supply chain for making them.
Very cheap.
and recycling them,
Yes. Yeah.
and
Well,
the safety factor, the
yeah.
charging, they, as I said, back 2017, it could change the world. But I've been waiting, and I'm hoping you guys do it. So yeah,
Well,
I'm hoping you get there.
when we do, we'll bring you in. You can see it.
Look, and there's a couple of comments. There was one comment you made at SIM-PAC Live Queensland, which I'd like to pick up on, and you said that Australia was leading the way in solar technologies, but we're also leading the way in battery technologies. And that raised my eyebrow, because I think that we've all read the media that China owns all the battery technology and China owns all the battery manufacturing.
Yeah.
And Australia has no manufacturing left. I mean, we've discussed that a little bit, but we're actually leading the way in some of this battery technology. I mean, there's you. And there's another Queensland company down the road that we had speak, straight after you, and Leaf in here from LIS Energy,
the most dense battery, in the world.
Yeah,
yeah.
So there's two world leading battery manufacturers in Queensland.
Yeah,
an hour down the road from each other.
Then you've got the vanadium flow battery, right, which is all developed in New South Wales, and there's a number of vanadium flow battery companies that are developing them in Queensland. If you haven't had them on, you should have them on. They're awesome as well. And vanadium flow is the future for large grid for sure. And Lich grid, and which is what we need for renewables. Renewables it needs grid capacity. It needs long lasting, low cost over time batteries that can take really reliable battery charges, and and then in really hot temperature, because let's face it, the world isn't sitting at 25 degrees C, which is what lithium ion needs for basically forever. It isn't sitting like that. And most of it is more than that or less than that. And lithium ion batteries don't like that. So you've got to spend a lot of time and effort managing the heat on them. So yes, Australia is leading the world. I mean, we arguably got the fastest charging battery out there, although in development. And I think LAS has got the most energy dense battery in development out there.
Yeah, the lightest battery for its energy.
So there you go. But then there's countless other types of companies that you've got through your organisation that are also doing pack development and virtual power plant kind of selling to grid, and also cell technology, charging structures, and it's quite simply amazing what's out there, and there's been almost no kind of understanding, I think, really that's the case in kind of broad community. It's interesting because the Chinese definitely are the largest producer of batteries by far, lithium-ion batteries by far. 90% or so, the whole value chain really, and most of it comes from Australia, Western Australia, minerals, or half of it does anyway, and then it goes through Chinese processing into a cell, which then eventually gets to someone's car or phone or laptop, and we then go buy it and use it. So it's this big circular, and that's okay. I think that's fine. That's good. We got to know our place, but we are absolutely leading the world in how to make disruptive battery technologies. But the mainland Chinese companies like CATL and those, they didn't invent these batteries. They made them better. But the first lithium manganese nickel cobalt batteries were invented at Oxford. And we actually worked with the guys, and they invented it, and they got nothing out of it. They've said this to themselves. It sounds bad, but so Sony went and used it, and used it in the camcorder, as the story goes, and they were the first to use the lithium-ion battery. And then lithium iron phosphate, which is the main battery we all see in all the batteries cars now, Teslas and all them, that was developed by an American company. And then that they went into solvency problems, and then a Chinese company bought it and scaled it. And so that's why they are the number one producer, because they took that risk and scaled it. And obviously manufacturing costs there are lower, but these are largely made by robots.
Automation
there.
Yeah.
And so, that could have, I mean, not that it could have happened anywhere. I think the way Chinese, mainland Chinese, supports technology and development is amazing, right? So that's another reason why it happened there. But that arguably could have happened anywhere, but it happened there because they supported the technology, they rolled it out, they had government frameworks. They wanted to try to remove from what I understand, they wanted to try to remove the smog from buses, and that was
Yes.
one of the biggest things they wanted to do was to move to the electric vehicle buses, and that's where it started. So it's completely self-driven by trying to create a cleaner environment for themselves. So, I think there's a lot of unknowns or misinterpretations of where we are now and why we got there. Any company that can work in this space, it's a highly democratized technology. This battery technology has got a lot of things left in it. It's nowhere near done. We're nowhere near as efficient as fuel and as liquid fuels, as we were saying before. And there are many elements to the battery development and supply chain. But right now, Chinese lithium ion batteries absolutely are very dominant. They got now a plant that's running with AI, so the AI actually runs the battery plant. So they're away, and you don't really want to come head on with that. That's an amazing machine. So really, I think Australian technologies to add on or be to the different side of a market or add different technologies which are different to the focus. That's what GMG is doing, and certainly LAS and many others are doing. And there's a massive space for that. It's just huge. It's
Right.
unbelievably massive, the space that's
And,
sitting beside lithium-ion batteries right now.
and look, one last question because we'll wrap up. But your company is focused on the American market for batteries, and just run us through, why you're focused on the American market, and also how you're finding the going out there.
Yeah, so we do see America really as the main market for our products. It is still the largest economy, and there is still something like $4 trillion of stuff that's made in America a year. I think it's the seventh largest country in the world by GDP. So there's, Australia, certainly Queensland, was really grew the last few decades supplying energy products to the Northeast Asia, and that made sense. And I think supplying coal and natural gas and other materials to those markets made sense. But I think really what makes more sense for us in the future is to supply energy products, energy saving products, energy storage products to the Americans, because they do genuinely respect Australian technology and science. We do come at things differently. We do bring that value to the table, and they do respect companies that come like that. And so we tend to just go getting stuff done rather than necessarily talk about it, and that kind of interests them. So I think there's a lot of broad assumptions there, but I do think America is where we could really support. They do want to make this happen, regardless of what size of politics. They do want to make these energy products or batteries or however you want to describe them in America. And we have not just minerals here, but we have amazing technologists and amazing scientists that can really help. And I think that's something we've got to reinforce time and again, that we're not just minerals. It takes a lot of work to get those minerals out of the ground. It takes a lot of work to get that out of the ground cheaply and safely every time and deliver a high quality product. That is not simple, and we need to understand that. And then that's a massive skill that we've got to find and eventually evolve into making other products. And America is definitely a great market for us.
Right. Great. It's a great chat. You and I could all chat for hours, but thank you so much for coming on the show. We'll leave it there. It was a good conversation. We covered all of the points I wanted to, And we're wishing you the best of luck.
Thanks, Jeff. Let's get you around to test the battery together one day.
Yeah, that'll be great.